Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student who obviously is taking calculus, because the squeeze theorem is something that's covered in calculus. And we want to find this limit. I'm just going to write it here just to make it a little easier to see. The limit as x approaches 0 of x squared times the cosine of 18 pi over x. So 18 pi over x is certainly not something we see every day. But when you think about the cosine, if we think about the cosine, the standard form of the cosine is a times the cosine of b times x minus h plus k. And you can see that there's no horizontal shift because there's no h and there's no k. And you can also see that the period is going to be complicated, but I'm not going to care what the period is. And you can see that the amplitude is 1 on this function, just ignoring the x squared, just looking at the cosine piece of it. And because the center line is at 0 and the amplitude is 1, whatever this curve happens to look like doesn't matter to me. All that matters is that this curve is always going to stay within these boundaries from between -1 and 1, simply because its center point is at 0 because there's no vertical shift k, and there's no horizontal shift h, although I don't think this would bother me too much, but luckily we don't have to deal with it. And the amplitude is b, but I don't care what the amplitude, the amplitude, the period is 2 pi over b, but I don't really care about that. And then the amplitude itself is just 1. So this curve, whatever it looks like, it has to have these boundaries. And so we can start this by writing the cosine of 18 pi over x. That monster has to be between 1 and -1. Now, what happens if we multiply everything now by x squared? Because this is what we're after, right? Now, x squared is always positive, so when I multiply through by x squared, I'm not going to change the direction of the inequality. So this is going to give me -x squared less than or equal x squared cosine 18 pi over x less than or equal to x squared, because a positive value changes nothing. Now the limit as x approaches 0 of -x squared, well, just think about the curve of -x squared. It's going to look like this. You know, it's just a parabola that's been flipped or reflected about the x-axis, and obviously the limit as you approach 0 is going to be 0. And we'll do the same for this piece up here, the positive x squared, limit as x approaches 0 of positive x squared. That's going to be 0 as well. The curve here is looks like this. So obviously that limit is 0. And because what's in the middle has to always be less than the left and always must greater than what's on the left and less than what's on the right, these two things are going to both approach zero. And the thing in the middle also has to approach zero. That's the squeeze theorem. So for squeeze theorem, you have to find the first setup an inequality that must always be true. And then at either end, hopefully the limit that you're seeking is the same for both sides. And therefore, whatever's in the middle, that limit must also be the same as the limit of these two guys, assuming these two guys agree on either end. And so we've just proved this, that the limit as x approaches zero of this little monster in the middle is going to be zero. And we're done. So the squeeze theorem is just, it's something that, it's not a big part of the course, but every once in a while it allows you to take a very complicated expression like this, which seems like impossible to work with, and because you're not thinking of the squeeze theorem. But if you do think of the squeeze theorem, sometimes you can take something that looks like it's impossible to find a limit of, and you'll be able to find a limit. So that's basically the use that this squeeze theorem has. Okay, so that's it for this one. I hope that was helpful, and I'll see you guys next time. Bye-bye.